Swayam Prabha. Digital India. Educated India.
Good morning and welcome to this next lecture on vibrations of plates and shells. So last class or last lecture I said we will look at Gauss Codazzi relations. So we will look at that. The Gauss Codazzi relations, they talk about properties of a surface, okay, surface properties. So one thing we need right at the beginning outset is that let's just take the example of a cylinder or a cylindrical surface. The R for the way we had taken x and theta as a right handed coordinate system was xi plus a sin theta j plus a cos theta k, okay, and from here del r by del x is equal to I, you can see. So del r del x is in the x direction, that's important, that's what I want to point out, okay, and del r by del theta is equal to a cos theta j minus a sin theta k. And if you remember, I was measuring theta from the z axis, okay, theta was measured from the z axis. So if theta is equal to 90 degrees, okay, this is 0, this is minus ak, okay. So right here the del r del theta is this way, okay, so it points in the local theta coordinate direction. If theta was equal to 0, then del r del theta is a times j, okay, here, okay, so it would point this way, which is again the local theta direction, okay. So del r del x points in the x direction, del r del theta points in the theta direction, that's important to note, okay. So now let us look at this thing called Gauss Codazzi relation. So the unit tangent vectors, in the alpha 1 and alpha 2 directions. What are they? We will call them T1 in the alpha 1 direction, which is now del r by del alpha 1. This will be in the alpha 1 direction according to this logic, del r del alpha 1 divided by the magnitude, okay. So we will use a notation, this is R1 comma 1 denotes derivative with respect to alpha 1 coordinate, and magnitude of this is A1, that we should know by now. Okay. Similarly, T2 is equal to del R by del alpha 2, magnitude of del R by del alpha 2, using the notation it is R comma 2 by A2. Okay. Next, the next thing is we have the unit normal vector. Unit normal vector. Okay. So, at some point on the surface we have a unit normal vector. Okay. So, if we move to another point alpha 1 plus d alpha 1, alpha 2 plus d alpha 2, then n bar gets a modification dn bar, but that is a unit vector still. So, the magnitude should still be equal to 1. Okay. And therefore, where could dn bar lie? Dn bar cannot have a component in the n bar direction. Okay. So, it can have only components perpendicular to it, and therefore, they will lie again in the alpha 1 alpha 2 plane, or alpha 1 alpha 2 direction, sorry. Okay. So, dn bar, if we write, there will be del n bar by del alpha 1 d alpha 1 plus del n bar by del alpha 2 d alpha 2. Okay. So, we will not use this form now, but I am just telling you. So, this will lie in the alpha 1 direction, this will lie in the alpha 2 direction, no component in the n direction, and therefore, del n by del alpha 1 and del n by del alpha 2 are perpendicular to the local normal. So, let us say now that del n by del alpha 1 lies in the alpha 1 alpha 2 directions, lies in alpha 2 and alpha 2 directions, and we have found T1 T2 B are unit vectors. So, it is a unit vector in the one direction plus some value B unit vector in the 2 direction. By the way, I have mentioned this is taken from the book by H. Gauss. Okay. I have mentioned it in the introduction. This initial portion I am taking it from a book by H. Gauss. Okay. So, let us see now, del n by del alpha 1 is this. Okay. Now, if we use the notation, okay. So, del n by del alpha 1 is n comma 1, that is the notation. If I dot it with T1, then I get R comma 1 by A1, this is T1 dotted with n comma 1, and this, by the way, is equal to L from our previous second fundamental form divided by A1. Okay. So, this is equal to A times T1 bar dotted with T1 bar plus B times T1 bar dotted with T2 bar. Okay. Similarly, if I do T2 bar and dot it with n comma 1, then that is equal to R comma 2 by A2 dotted with n comma 1. If you remember, T2 is del r del alpha 2 divided by magnitude, which is A2. That's what is written over here. Okay. Then this is equal to a part of M from our second fundamental form A2, which is equal to A times T2 bar dotted with T1 bar plus B times T2 bar dotted with T2 bar. Okay. Now M is having two components, and it is such that each of the components has to be 0. So this has to be 0. This is one part of M. Okay. If M is 0, each of the parts is 0. It is configured, or the formula is such, or the surface properties are such. So this is 0. This is 0. And T1 dot T2 is also 0, and therefore B is 0. That implies that B is 0. B is equal to 0. Okay. So that means what now? My original n comma 1, okay, original n comma 1 with B 0 is A times T1, okay, which is equal to L by A1 T1. Okay. Now my curvature, one of the curvatures, principal curvatures, let me do the kappa here, and hence 1 over R1 is L by A1 squared. If you remember the ratio of the second fundamental and first fundamental form. Okay. And therefore what happens now? Here L will be equal to, okay, A1 square by R1. So I will have A1 square by A1 R1 T1. So del n by del alpha 1 is equal to, if I cancel this out, I get A1 by R1 T1. Okay, so this is one formula we will use. Okay. Similarly, del n by del alpha 2 is equal to A2 by R2 into T2. This is also another formula we will use along the way. Okay, the occasion will come. Now we will need T1 comma 2. Okay, what is T1? We have alpha 1 direction, we have alpha 2 direction, and the normal. So T1 lies in this direction. Okay, so it is derivative of T1. T1 is again a unit normal, I mean unit vector, sorry, unit tangent vector. Okay, so its derivative will lie in the n and alpha 2 plane. It will lie in this plane, it will lie in that plane. So T12, so T12 I will write as a component in the normal direction plus a component in the other sorry, it will lie in the T12 because T1 is a unique vector, T12, my mistake. T12 will have, so if this is T1, it will have no more components in that direction, it will have components in alpha 2 and n, my mistake, alpha, this is the plane, alpha 2 and n, okay. Okay, so that's what I have written, that's what I have written over here. Now how to find C and D? Okay, so we will have n dotted with T1 comma 2 as C, okay, and T2 dotted with T1 comma 2 as D. Okay, so now we have to find out what are these C and D. First of all, n dotted with T1 is 0, so this normal and tangent, okay, and therefore n dotted with T1 differentiated with respect to alpha 2 is equal to n differentiated with alpha 2 dotted with T1 plus n dotted with T1 differentiated with respect to 2, but this is 0 anyway, so this is also equal to 0, this is 0, 0, okay, which implies n dotted with T1 comma 2 is equal to minus n differentiated with 2 dotted with T1. Okay. Now this part is, this is what we want, this is what we wanted, okay, as our C. You remember this is what was C was, and then del n del alpha 2 lies in the alpha 2 direction, okay, and T1 points in the alpha 1 direction, so this is equal to 0, which implies C is equal to 0, C is equal to 0, okay. Next we have T2, so next idea, T2 dotted with T1 is already 0, and therefore T2 dotted with T1 2 is equal to T2 comma 2 dotted with T1 plus T2 dotted with T1 comma 2, that is again 0, because this is already 0, which means what? This implies that T2 dotted with T1 comma 2 is the negative of T2 comma 2 dotted with T1, okay. So now we use what we have already found, okay. So what have we found? T2 dotted with T1 comma 2 is equal to minus A2 by R2 into N, okay, minus 1 by A1 del A2 by del alpha 1 T1 into minus 1 dotted with T1. Okay, and therefore my D is equal to 1 over A1 del A2 by del alpha 1, okay, which implies that T1 comma 2 is equal to 1 over A1 del A2 by del alpha 1 T2. Okay. Similarly, T2 comma 1 is equal to 1 over A2 del A1 by del alpha 2 T1. Okay. So let us make a note of this here. T1 comma 2 is equal to 1 over A1 del A2 by del alpha 1 T2, and T2 comma 1 is equal to 1 by A2 del A1 by del alpha 2 T1. Okay. Now, what do we have from above? From above we have n bar comma 1 and n bar comma 2. We have these two. So what are they? A1 by R1 T1 is equal to n bar comma 1 and A2 by R2 T2 is equal to n bar comma 2. Okay. Now we are looking at a surface which is continuous. Okay. So therefore n bar comma 1 2 is equal to n bar comma 2 1. Okay. So if we take that A1 by R1 T1 and the derivative with alpha 2, which is n bar comma 1 2, that should be the same as n bar comma 2 1, which is equal to A2 by R2 T2 comma 1. Okay, so these two are equal. If we proceed with these two now, if we proceed with these two and open out, what we will have is A1 by R1 comma 2 T1 plus A1 by R1 T1 comma 2 is equal to A2 by R2 comma 1 T2 plus A2 by R2 T2 comma 1. Okay. Now we are going to use T1 comma 2 from here and T2 comma 1 from here. Okay. So if we do that, what do we get? We get A1 by R1 comma 2 T1 plus A1 by R1 T1 comma 2 is 1 over A1 del A2 by del alpha 1 T2 is equal to A2 by R2 comma 1 T2 plus A2 by R2 1 by A2 del A1 by del alpha 2 T1 bar. So this cancels out, this cancels out. I have T1, I will collect. I have T2, I will collect. Okay, if I do that, I get T1 A1 by R1 minus 1 by R2 del A1 by del alpha 2 is equal to A2 by R2 1 minus 1 by R1 del A2 by del alpha 1 T2 bar. If I bring it onto one side, what I have T1 times something plus T2 times something else equal to 0. Okay, so these, if we look at the surface now, this is alpha 1, this is alpha 2, and T1 is the unit tangent vector, T2 is the unit tangent vector. They are perpendicular to each other and linearly independent, and so something in T1 and something in T2 added goes to 0. Then it must be that this is 0 and that is 0. Therefore this term is 0, which gives me a 1 by R1 comma 2 is equal to 1 over R2 del A1 by del alpha 2, which is very interesting. See, R1 has become R2. Then A2 by R2 1 is equal to 1 by R1 del A2 del alpha 1. R2 has become R1. These are the Gauss Codazzi relations. We will use them later. Okay, so time has run out for today. I'll close. We'll begin in the next class. Thank you.